screen now?
Yes, we can see the screen. Yes.
Okay, so just 10 minutes to also enthuse the participants, some of them who may be thinking, where does this kind of a work on the phase field simulations of microstructure evolution fit in the larger perspective of computing, not just in India, but also across the world. If you look at the top 500.org website, which keeps track of the fastest computers in the world, so they are all actually hybrid systems. They all have GPUs and CPUs. So if we are working on software which are able to scale up to the hybrid systems, that means that we can actually go and solve bigger and more complex problems, because that is the direction in which the fastest computers in the world are moving. And this is what we mean by those heterogeneous or hybrid clusters, where we have got CPUs and GPUs. So if you are actually investing money in procuring a software, then we should imagine that it should be able to work on these kind of clusters, because then we can scale up to bigger problems or more complex problems. And if you look at where are we in the world with respect to the high performance computing, we slipped a little bit in the past, but I think now we are going up. So we are actually at the 17th in the world. Naturally, the top countries are known to all of us. China and US are doing very well. So this percentage will increase very shortly, because NSM clusters are actually getting launched. And if you look at what kind of segments of the research industry, academia, etc., that are occupying the computing landscape, you can see that academia, though in India it's the largest host of the high performance computing, actually across the world it is the industry and research that takes most of it, which means that those who actually learn to run their codes on high performance computing have a huge scope across the world. And what kind of operating systems do these supercomputers use across the world? It is 100% Linux, okay, 100% Linux. So which means that if you have been using Ubuntu on your laptop, you are well set to do most of the work on your own in supercomputers. And so that is something good, that you should migrate, get rid of any other operating system on your laptop and switch to Linux soon, because then you are getting more ready to HPC. And the kind of accelerators that are in the top computers in the world are also listed here. NVIDIA is leading the pack. If you see generally the kind of research across the world, of course, US and China are way ahead of other countries like India and Germany. But of course, India is doing very well with respect to the Germany. And if you look at engineering, actually, we are doing quite close to US. China is way ahead, of course, but India is doing very well, if you see here. And we have crossed Germany in terms of absolute numbers, maybe not in terms of certain impact, but definitely in terms of quantity, we are doing quite well. And particularly in material science, we are doing very well compared to Germany, and we are approaching US. So which means that in material science and research publications in India, we are doing very well. And what about the kind of topic that this MicroSim is going to support? That is the integrated computational materials engineering. So this is a topic that is growing in the last several years across the globe. So you can see the growth here. Number of publications is just keeping on increasing. And if you look at the number of publications and which country is publishing, so we are actually very well placed. So you can see the countries ahead of us, they are all the usual suspects, but we are actually in the top 10 in the world with respect to ICME. So it's a very golden opportunity that we can jump in and make it even more prominent using the software tools. And we are keeping it open source. So I hope it will encourage more people to get in. Now, if you look at global position in India, of course, China has crossed in US a couple of years back, and in India we are like around 15th to 20th position, and Germany is actually fourth, which means that compared to the global position in computing power, India's research output is actually much better. So we are putting our brains to good utility, but we can actually even do more if more facilities are available to us. And in terms of system share, we have very few systems in India. We are not counting those in ISRO or DRDO, but still, we have very few systems compared to the our competing countries across the world. But given that our research output is again very good, which means that we should be looking forward to more infrastructure coming our way, and we can do even better. And the peak power, if you see, our computing power is much lower than, let us say, China and America, but our programs that we are writing today are scalable, which means that as more resources are accessible to us, we will be able to solve bigger problems and more complex problems from the country. So some broad remarks. National Supercomputing Mission is adding computers every year. A couple of them will be coming in. So we are looking at a very good time ahead for computing work in the country. And I want to also mention to you, I'm part of an effort from the Indian National Academy of Engineering, and I can say that they are working hard to release a roadmap document on ICME. So it will be made public as and when it is out. So then we will know how this kind of research will be progressing in the country. There is an ICME hub at IIT Kanpur. We are all part of that, and they are conducting several events. So please do look out their website for events that are coming up. And several ICME projects are being supported by various funding agencies in the country. So it's a time that you can start investing in this effort. And in fact, anybody who has a credit card and knowledge to run a parallel computing program can actually start using it independently, because Microsoft's cluster is actually ranked 10 in the global list, which means that it's actually the public cloud that is ready for high performance computing. So those students who learn Linux and programming actually have very good opportunity ahead in HPC problems. So keep pushing yourself. And unlike other black box purchases that people do, particularly, let us say, very expensive microscope, in the case of supercomputing, it's all hands-on experience, and you are actually learning with skills that you can go and transfer to other locations. So your effort is going to get you much more returns. And with that, I thank organizers for giving me this short time. I have put up a website containing some resources to learn the kind of background knowledge that can help you in making the most out of the high performance computing. Feel free to use those resources. They are all free. And get back to us to help you to make more out of this kind of an environment in future. We'll be happy to collaborate and support. So thank you, Abik. We are done with that very quick, brief remarks from my side.
Thanks, Funny, for that nice overview of where we are placed, and how the community should perceive our work and where it is placed in that.